We'll be back, guys. This is Teacher Edward taking us through measurements of dispersion. So earlier on, we looked at different methods or different measurements of dispersions that we say, among which was range, variance, standard deviation, interquartile range, percentile, and decile. But we decided to start with the first three, which was range, variance, and standard deviation. That now we are going to look at those last three, which are, we are going to look at interquartile range and a percentile, and then decile. So the first one to start with, we shall start with what we call quartiles. What are they? These are values that divide a given value into 4 equal parts. We say that the quartiles are values that divide a given value. It may be of distribution into 4, that divide the given value of distribution into 4 equal parts. So by dividing the value into 4 equal parts, implying that there are 4 equal subsections. So now the first one, we have the lower and the upper. Because if you divide the given value into 4 equal parts, and then that value is as a result of cumulative frequency, and we know that cumulative frequency always it accumulates, that it does not reduce, implying that it will start from the smallest going to the highest. So if you divide that cumulative frequency into 4 parts, then obviously you will have the upper part, you have the lower part, and then you will have the middle part. So for quarters, we shall have the first, which we are calling lower quartiles, and we denote it as, which is denoted as Q1, and then it is defined by, defined by Q1 equals to 1. It is the first part, but out of those parts, out of the 4 parts, it is the first part out of the out of the 4 parts. That one make it to have 1 out of 4 of n. See, value. Then what is our n? N is the total number of variable. N is the total number of variable. So all of you are wondering, what is the quarter of n's value? What is that n's value? That n's value come from cumulative frequency, or is the value which you take or you read from cumulative frequency, and then you come and note the corresponding variable. So this value is as a result of cumulative frequency. Otherwise, we can say Q1 is a quarter of 4 of n, is the value of cumulative frequency or from cumulative frequency. All of it will be the same. Even if you stop here, it may make some sense, but if you want to proceed, you take note that this value is from cumulative frequency, not from any other part. So after getting the first one as that one, obviously we shall have the middle part, which is Q2, and then Q2 will be 2 out of 4 of n's value. Still n is the total number of variable. Then we shall have the upper part, which is Q3. This one is the lower part, this one is the middle part, this one is the upper part, which is Q3, and is given by 3/4 of n's value of cumulative frequency, or we can say from cumulative frequency. Then after obtaining the three parts, we have what we call interquartile range, which can be located in the middle, which can be represented by Q2, but numerically we get it by subtracting all the difference between the upper quartile minus the lower quartile. So this one obviously it will become upper quartile, which is Q3 minus Q1. Then that one become our interquartile range. Then if you want to get semi-interquartile range, semi-interquartile range is given by semi-interquartile range is given by a half or interquartile range divided by 2, or you can say it is a half of interquartile range. From your ordinary level, that if you have something which is a circle which is 1 and you get a semicircle, means it's half of that circle. So this one become, now substituting the value of interquartile range, it will become a half of Q3 minus Q1. But we said Q3 is the upper quartile range, and the Q3 is the upper quartile, and then Q1 is the lower quartile. These are the formula we shall be using to calculate the quartile range and the semi-quartile range. Then we shall look at how to calculate in the exam.